don't care. As long as it gets done. What?
Do you have a pencil?
I do. They're in the blue cup over there.
If I don't like one of my professors, I'm gonna walk out of class.
Mr. Brain won't stop you, but he just.
I'll open the door for you if you want to go.
But he will not.
If I don't like one of my professors, I'm not gonna have class.
You know what? They won't care because you already paid your money. So they don't care. You've already paid your money. You pay your money. You bomb out. They keep your money.
There was a meme, and it was like, "Oh, well, you're an adult. You can just walk out my class." And you're like, "Oh, okay."
You don't even have to go to well, some professors do great on attendance, some don't. I would go the first day and figure it out. But if you don't show up to college, they don't care. They got your money.
So if you drop out of the class, you still pay for it?
Yes. And you take an F in it.
No matter what, you already paid for it.
Correct.
And if you see with an A and then you drop out.
Jimena, my son just found out that his teacher, because he couldn't get a higher grade in it, he decided not to do the final for the teacher, not to do it completely. So she went back and docked him points for assignments that he had already done and then changed his grade to a lower grade.
That's stupid.
Well, that's what she did. And unless he goes to somebody and fights it, it goes through, and so he has to deal with it.
What's your class code?
Hang on.
Hang on.
Hang on. There you go.
That's a sweet.
So, again, professors in college is a lot different than high school.
Oh, there. Go to work.
Struggling muffins, fondly X-ray, underwhelming.
Correct. That would be the one.
You might have said the one fair class up.
No, wait. How? Muffins on the X-ray. I do. Well.
Don't try to make sense out of it, Zoe. Don't try to make sense out of it. They randomly generate words to fill their phrase. It's okay. All right, ladies and gentlemen. Welcome to Monday morning. What? Well, what do you think those are there for, sir? Yeah, that's why I got them there. Just come up, grab one, go ahead and use it. That's what they're there for. Bring it back when you're done. That's all I ask. All right, ladies and gentlemen. Enter in that code. In a minute, I will hand back your quizzes from Friday. We will give those to you. We will go over those as well. You know what? Might as well start with those. So that way you have more time to get logged in. All right. Christian. Brianna. Ethan.
Yeah.
Lucy. Karen. Well, it doesn't have to change anything either way. Ethan. You've been Mariana. Alex. Faith. Victoria. Christopher. Helen.
Did you get 65%? I got 60.
Oh, sorry. Okay. All right, ladies and gentlemen. First of all, when I show you the answers, there were two versions, so make sure you're looking at the right version of the quiz. We'll begin with those of you who had version 1 of the quiz. It's at the top says Conceptual Chemistry Unit 5, Quiz 2. If you had that version of the quiz, ladies and gentlemen, here are the numbers that you were supposed to put into the assignment. Now, again, I gave you the formulas. So, Energy in little c cals is equal to the mass of water times the change in temp of water. From these two numbers here, just like in your lab, you could find the mass of water. From these two numbers here, just like in your lab, you could find the change in temperature. And from these two numbers at the top, just like in the lab, you could have found the mass of food burned. So you take the number for the mass of water, you take the number for the change in temperature, you do the math here, which is to multiply them together, and you get this answer, ladies and gentlemen. 1 point for the number, 1 point for the unit, 1 point for setting it up. That's your 3 points in that problem. Questions? In the second part, we are converting little c calories into big C calories. To do that, we put 1 big C calorie over 1,000 little c calories. We do the math, and that's what we get for an answer here, ladies and gentlemen. So that is a 2-point problem. And then finally, ladies and gentlemen, on the bottom, to find the calories per gram burned, we take, again, the mass of water, the change in temp. Here is the grams of food burned times that 1,000 to get it into big C calories. And that is what we end up with right here, ladies and gentlemen. Again, 1 point for the number and 1 point for the unit on that answer. Are there any questions? You should have done this calculation 6 times in your lab. Now, the problem is some of you still haven't turned in your lab, so I guess you didn't practice it very much. But that was the same exact calculation that we did in the lab 6 times to find the calories per gram, and then we actually took those and found the averages of them. So, if you had version 2, ladies and gentlemen, you did the exact same thing. The only thing that changed were your numbers up here. So this is now the change in the grams of water for you. This is the change in temp, and this is the amount of food burned. You still took the mass of water times the change in temp. You got the calories in little c calories. Took that number and converted it into big C calories using the same conversion they did on version 1. Got to that answer, and then we've calculated the calories per gram of food burned. Again, mass of water times the change in temp over the mass of food burned times that 1,000. There was your answer that you were supposed to get. Questions on either one?
And the back.
Okay, let's go with version 1 again. Actually, I can put both up here at the same time. On the top is version 1, and on the bottom is version 2. They're the same exact questions, just in a different order, ladies and gentlemen. So, for the top one here, which is the middle one here, okay, if there is no change in energy, but the amount of water that you're using increases, that will cause the change in temp to do this, ladies and gentlemen. And because these are going in this direction compared to each other, that should have been your relationship. The mass of water here is the same as this one down here. So again, if you're not changing the mass of water, but you're increasing the amount of energy you're adding, this is what it does to the change in temperature. And because of the directions these are going, that gives us this kind of relationship. The last one here is the first one here, ladies and gentlemen, and that is the no change in temp, but the mass of water increases. The amount of energy you're going to need to get the same change in temp does this. There's your relationship. That's what you should have had. Okay? Now, for some of you, you got this one wrong. Okay? Maybe you put it in the wrong direction. But if you identified the correct type of relationship still, I should have given you the point. So in other words, if you have one of these going up and one of these going down, even though it wasn't supposed to go down, and then you called it the correct kind of relationship, I still gave you the point for that type of relationship. Okay? If you did not get it correct, I did not. And by the way, if these were constant, there is no relationship then because that's not changing. Okay? So that should have been your hint that none of these should have been constant. Okay? Questions, ladies and gentlemen? Jennifer, after you set your stuff down, we're going to put you next door to take the quiz from Friday. Okay. So pick a seat, and then we'll have you go next door with Kevin. Do you have a calculator, Jennifer? Okay, can you grab one, please? Thank you very much. All right. All right, Jennifer. I'll be back in a minute, ladies and gentlemen. Please make sure you're logged in and on the fair deck.
I got a coffee stain on here. My coffee spilt this morning.
All right, ladies and gentlemen, thank you for your patience. All right, so today then, ladies and gentlemen, let's get back to where we were. All right, you're going to do an electrolyte lab. We've heard about electrolytes. What's a good source of electrolytes?
Like Gatorade, kind of.
Gatorade. Now these new Pedialytes are good sources of electrolytes and things like that. So we're going to look at electrolytes. We're going to determine if 9 household substances or 9 things that you will find around your home are electrolytes or not. We're also going to learn what an electrolyte is. If you did not finish your carbohydrate worksheet, which only one person has turned in at the start of class today, get that done. It is due by the end of the day today, so you'll have some time to work on that. Today, you will be able to understand what an electrolyte is. Again, tomorrow, ladies and gentlemen, tomorrow you will not be here. Tomorrow it will just be sophomores and freshmen here. So you need to go online into Google Classroom. You need to check the stream. There will be a couple of short videos that you have to watch there, and then you will have time to finish your lab that is due tomorrow that we are starting today. Also, you can use it as a day to get caught up on anything you're missing, like the lab from last week that may or may not have been turned in. On Friday of this week, ladies and gentlemen, we will take our unit test because we have spring break next week, or whatever they're calling it, spring break, whatever. Anyway, if you are going to be gone on Friday and you know you're going to be gone, you need to let me know. I can give you the test on Thursday. If you choose to wait because you're going to be gone on Friday, you will take it on the Monday that we come back after spring break. Okay? So I'm giving you choices. If you don't take one of those, that is the choice that you will have, which is you will be doing it on the Monday after spring break. Okay, ladies and gentlemen, I think that covers just about everything. So let's get going today. And what are the 3 common elements found in both lipids and carbohydrates? And I know we haven't talked about lipids, but they're the same 3 that are in carbohydrates. So tell me what the 3 common elements found in a carbohydrate is. You can give me their symbols, ladies and gentlemen. All right, the 3, sorry, Those are the correct 3 responses. I didn't realize I was going to show you. All right. So the 3 elements, ladies and gentlemen, are carbon, hydrogen, and oxygen. Those are the 3 things that are in any carbohydrate. By the way, those are the 3 things that are in any lipid that we will learn about on Wednesday. Okay? Whether it's a carbohydrate or whether it's a lipid, that's what's in both. Okay? What is another term for saccharide? What does saccharide mean, in other words? Either one you can use. What is another term for a saccharide, or what does saccharide mean, ladies and gentlemen? By the way, this will be something that is on your test on Friday, is what does the term saccharide mean? So what does saccharide mean? Okay? Means sugar. Means sugar, ladies and gentlemen. A saccharide is a sugar. Okay? A saccharide is a sugar. Okay? What is present in the carbon chain that makes, never mind, you can't do this one, ladies and gentlemen, so we'll just skip it. Okay? What does the prefix di and the prefix poly mean? So please tell me each. So when you write down an answer, tell me what di means and then tell me what poly means. Christopher, what's di mean?
Nine.
Yep. Okay, it represents a number. Do you know what number? Okay, Mariana, do you know what number it represents? What? 2. Di means 2. What does poly mean? Helen, do you have a question, or are you trying to answer? I'll get you one in a second. What does poly mean? So go ahead, Zoe.
Many.
Poly means many. Di means 2, poly means many. So in a disaccharide, you have 2 simple sugars. In a polysaccharide, you have many of them. All right. Here you go, Helen. All right. So that's it for today, ladies and gentlemen. All right. What I would like you to do, ladies and gentlemen, is open up Google Classroom. And in Google Classroom, you will find the assignment for Electrolyte Mini Lab. Click on it and open it up, ladies and gentlemen. And it looks something like this. Okay? Looks something like this. Did I post it the wrong way?
Yes.
Okay, give me just a second here. I will make that assignment go away. Just close it down, please. Sorry about that. Sorry about that. Yep, I forgot to make a copy of it. Okay. All righty. All right. Create assignment. All right. Again, if you were in that document, please close it down because you cannot turn it in. You would have to reshare it back to me, and this is going to be easier for you to do, ladies and gentlemen. So now let's open up the right document, which should be posted there, which is the Electrolyte Lab. And now when you open it up, ladies and gentlemen, it should have made a copy of it for you, so you do not need to be on my copy anymore. Okay. All right. Because it will not let you type. Well, it might let you type on mine. Hopefully it doesn't. Okay. So real quick here, ladies and gentlemen, go on Google, find the term for electrolyte. What does it mean to be an electrolyte? And find 3 common examples of household substances that are electrolytes. Could be drinks, could be fluids that are around your house, anything like that, ladies and gentlemen. We're going to give you about 3 minutes to get this done, ladies and gentlemen, and then we will move on to the next part. So go ahead and find out the definition of an electrolyte and name 3 common household solutions that are electrolytes, so something that is in either water or liquid form.
I didn't know that.
Well, good. I'm glad you learned something today.
Mm-hmm.
Is there anyone who needs more time for those 2 questions? Okay. And what I'm going to ask you to do, ladies and gentlemen, is for what we're about to do on the lab, you are going to need to bring up a program on your computer. So down in the lower left-hand corner, instead of the Windows symbol, you have a circle down there, ladies and gentlemen. Please click on that and open up your apps. And what you are looking for, ladies and gentlemen, is this app right here. It says Vernier Graphical Analysis. It is the same symbol as you're seeing on mine. So yours is probably round, but it is the red line, red wavy line, and a blue dotted line underneath it. So please open that up and bring that program up. If you haven't ever used it before, it takes a long time to open up the first time. If you have used it before, yes, sir. If you have used it before, it should come up fairly quickly. But if not, that's okay. We don't need it right this second. Is there anyone who needs help finding it? No. Yep, that's the one. Okay. Now, in a minute, ladies and gentlemen, you are going to go in back. And in back, you are going to, after you partner up, one of you is going to get a cord like this out of the tall or out of the short box on that cart right there that says Husky Room 214. You will also get one of these that says LabQuest Minis. In the other box, you will get one of these conductivity meters. Okay? So those are the 3 things that you're going to need to get when you go into the back. But if you're working with someone, only one of you needs that. Now, you can go back and forth between this Vernier graphical analysis and between your lab at any time. Okay? So let's show you what you're going to do in the lab. The purpose is to determine what an electrolyte is. You just defined that. And determine what substances are electrolytes. I have 9 different solutions for you that we are going to test today. We are going to determine which ones are electrolytes. Now, you are going to take a reading with the meter like this. That meter is going to give you a number. The question is, what does that number mean? So afterwards, we're going to do a simpler test to show you what an electrolyte is and what an electrolyte does. And that will help you understand the reading that you got in the lab, hopefully. Okay? Now, what's going to happen, ladies and gentlemen, is after you plug everything into your computer, you are going to take and you are going to start up a program and you're going to do some things to it. This will talk you through it. But basically, there are 9 beakers on each side of the lab. So the 9 that are on this side of the main table in the back and the 9 that are on this side are the same. So when you go to the lab, if you're working on this side, please take the solutions off of this side. If you're working on that side, please take the solutions off of the other side. Now, there are only about 10 groups in here or so. 2, 4, 6, 8, 10. There are 16 of us, so there's 8 groups. So each group could take one sample and use it, and there would still be one left at the table. So you've got to go through and you've got to share them. Again, you are going to make 3 observations of what you see. 3 observations. You can smell, you can feel, you can observe with your eyes. Please do not taste anything. Even though many of these things are consumable, I don't guarantee that the beaker that I put them in was perfectly clean when we started out. So I would appreciate it if you did not drink them. Okay? So in here you are going to make 3 observations and then you are going to get a meter reading. Okay? Now, here's what I mean by a meter reading. This cord that you get can only plug into one spot on here. You plug it into there. Then it is a USB cord that goes and plugs into your Chromebook. This probe can only go in, well, it can go into multiple ones, but it can only go into the ones that are at the opposite end of where you plug this into. And there are 3 of them here, and it doesn't matter which one you plug it into. Now, there is a switch on here, ladies and gentlemen, up, middle, and down. Please make sure that is in the middle. That is in the middle, so we are all reading in the same scale. And now this is ready to use, ladies and gentlemen. But you need to follow the directions on here so that you can get your display reading how we want it to. So when you plug it in, it should automatically detect the probe, ladies and gentlemen. So mine automatically detected the probe. The problem is I don't need a graph here. So I'm going to click on this box here, this box in the upper corner, and I'm going to shut off the graph and I'm going to turn on the meter because all I want it for is the numbers. So I click off the graph, I click on the meter, and it's going to give me a reading here. Okay? Now, it is reading a number, and that's okay. It's like the balance. It's okay if it's reading a number. But you're going to start by taking your first substance, whatever it is. So mine is deionized water here. You're going to put the meter in there, ladies and gentlemen, and you're just going to let it sit in there for a minute or 2. And it is now giving you a reading. Okay? It is now giving you a reading. You are going to write down that number underneath the 3 observations that you make. Okay? Now, again, it's not going to stay perfectly still. You write it down. Now, later on, we're going to compare these numbers. Big number, little number, we're going to put them in order. Okay?
And your partner might have different numbers.
No, your partner shouldn't. They're working with you. Now, here is the one important thing. After you put this meter into a solution, you need to clean it off. And that is what this beaker is there for at your station. You simply take and swirl this around in it for a minute or for a few seconds, and now it is good to go to your next solution. Do not go directly from one solution into another. You will contaminate the solutions, and you may get a false reading because of it. Okay? Yes.
So when we dip it in the water,
Which water? This or this one?
The big one.
Yeah.
Should we dry it off?
Nope, don't dry it off. Just dip it in there, swirl it around like this a little bit, move it around, and then you're ready to go for your next one. Okay? So all you're doing is rinsing it off in there. Okay? Now, the part that we need to get done is this. We need to get this information collected. Why? Because then at the end, ladies and gentlemen, I need to do a test up here to help you understand what those numbers that you're getting mean. So, you're going to go around. Actually, let me rephrase that. You are going to bring these solutions over to where you are set up at a lab station. You are going to make the observations. You are going to test it, and then you return it back to where you got it from. And you grab another one. You need to get all 9 done. Please don't go and grab 4 of them and take them to your station right away, because then no one else can use them. Okay? So, get those done. Now, again, 3 observations and the meter reading for all 9 solutions. When you are done with that, ladies and gentlemen, you need to take and put them into this table in the order of their readings. Okay? So we want them in order of their readings. So now you're going to have to work with your partner. They can look at the numbers. Okay, what was the lowest number? That one goes first. So tell me what that was and what the reading was. Then do the second, then do the third, then do the fourth. If you have to move things around a little bit, I could show you how to do that and help you with that if you accidentally put something in the wrong place. But you want these in order of their readings, from lowest to highest. And that's what you need to get done before we do this next part. Did the light bulb turn on or off? We got to get that done today. So I need about 5 minutes, maybe a little bit more. So really, we need to be done in about 25 minutes, ladies and gentlemen. Going back, go to work on your lab. Grab your stuff. If you need help setting something up, raise your hand. Call me over. I will be happy to come over and help you. So there are 2 people in every group. You can work at any station you want.
So it has to be somebody in this room.
Yeah, there should be 2 people. There are 16 of us in the room. Or did I count wrong? No, we're good. Okay. I thought maybe I counted wrong. Nope. They'll come over and they'll get their information from you.
It's good.
What? No, 1 set for the 2, but you do need all 3 things. So you need that, you need this, and you need that. You're welcome. When you get everything plugged in, call me over when you have your Vernier software up, and I will make sure everything is working correctly. The one of you who is not plugging it into your computer could shut down the Vernier software on your computer. You only need it on one of the 2. Okay, so who's putting the software into their computer? Okay. So you can close down the software on yours. There you go. So it should be one of, on the bottom bar of your computer, ladies and gentlemen, it should be on there. You can close it down if you don't need it on your computer.
Okay.
Everything is labeled. Every jar has written on it what it is. Please don't spill it.
It depends on the.
Do you not grab all those pieces?
It's dark. There's bubbles.
Oh, wait, okay, I got it.
You're gonna start yours.
Right?
Right?
But it's just wait for me to Okay, you wanna write that down?
I just had that.
How long do you have to let it sit for? This is good. Milk. If there are things that you're reading and they start here.
Yep, definitely.
You just stand here. You're not gonna be ready to go grab a solution. We're good. No, you're good. I didn't mean it like that. I'm sorry.
Whoa. Back up.
Whole grain.
In a minute, we may try to have. Let's try that. I don't know.
One, two, 6, 9.
25. 5.
Hold on. It doesn't matter. It just.
You want the number?
In order? I know.
Close as you can get.
No, I know it didn't. Like, it didn't order.
The number.
Yes,
Take these out of that.
right there, hanging behind the second brush from the right.
So I just put them in this little thing.
Here goes generate.
Yeah. How about you? Or 2 Yeah, it's
You're just putting this in there. You're putting this number in your graph. That's all.
Oh,
you're
yeah, I know.
doing. Alright, go get them.
I didn't know if there's gonna be like a graph or something.
No, that's why he said you don't need the
This
graph.
Soda.
Okay, so do this.
Just make sure you make your observations, and then
Me too.
you can get your stuff from Victoria after. Yes.
Or
Because you're gonna have the same observations.
I
I mean, you can do your observations, you should be able to remember it, you just don't have to write it down.
There we go. There we go. Because for some reason your computer just didn't like it.
Frozen?
You guys are good?
Yeah.
No, it's great.
Ella, Lucy, you guys are good?
Yeah.
Okay, excellent.
did that. I put word in
You're good? OJ. OJ, you guys are good? Okay. Brianna, Alex, you guys are good? Excellent.
What'd you do?
Okay.
One.
I know we supposed to take the reading. It started at like 250, went down to 200, and now we're back to 220.
Smells.
Did that one. The first one.
It's boring.
I put clear.
Okay, take it out, rinse it one more time. Rinse it.
Like water.
Put it in, put it back in.
Yeah. It was like water. 270.
Yeah, go 270.
Right around.
There you go.
7.
Clean it, and go get a new one.
We can't put Renier.
Feel it. Smell it. It's water.
8-6, right?
All it is water that's had the iron. I wouldn't have you stick your fingers in something that was not. You weren't able. Does it feel slippery? Does it feel sticky? Does it feel smooth? Shut it.
Let's do fields.
Or pretty good. Good. If you keep swirling it around, it's going to keep moving. The best thing to do is rinse it off, put it in there, get the measurement right away, and
You said what?
because again, no, that's fine. Moving it around though doesn't always seem to help. Okay. Yes. What do you mean you broke it? I'm positive. Lost 2 electrons. I didn't know. Jennifer, should we grab your computer and start working in with the group?
No, that's so funny.
No, they have the same problem. You guys had it working, right? So no letter both.
You put that in there.
So,
What? Equals
7. Looking at 45. Okay. Next one.
Oh, I
2, 1, 4.
311.10.
there's no reason.
You got one.
You want to?
Yeah.
Are you?
Oh,
24?
what?
Do you want to do like 37.0?
They're not wet, we got issues.
But it's still an observation.
I'm not saying it's not.
Is it sticky?
So sometimes people try to get too tricky with their observations. Well, to be honest,
Is it sticky?
if you
And
do
then I put clear.
odor, if you do how it feels, and you do one observation of how it looks, you got your 3 days. You can jump in with whatever group you would like, Jennifer.
Bro, we could spend until now, bro. That was like a shot at like the block right at the layup, but we didn't take after. So
I can change it.
for me, but I don't think that's
We got
So, 1 or 2.
All right, ladies and gentlemen, we have one final test to do for this lab. Now, you collected all those numbers for conductivity, but to be honest, those mean nothing to you right now. Is a high number good? Is a low number good? We don't know. So we're going to do one more test. And the test is called the conductivity. What's an electrolyte? What was the definition of it?
It's I got you. Oh my, I ain't gonna lie, mine's pretty long.
Substances that have a natural positive or negative electrical charge when dissolved in water.
Okay. Now, when an electrolyte has positive and negative particles when dissolved in water, it will allow the water to do something special. It will allow the water to conduct electricity. So what we have up here is an apparatus that is going to tell us if our solutions will conduct electricity. And the way it will do it is if the light bulb lights up, our solution does conduct the electricity. So in the last column, when we go through each solution, if it lights up, you put yes, and if it doesn't, you put no. We are going to begin with deionized water, ladies and gentlemen. So for deionized water, I'm going to take it, I'm going to put it in under the water, and does the light light up?
Do we have to wait or wait?
Do you see it light up?
No.
No. So for deionized water, no, it does not light up, ladies and gentlemen. Okay? Next, we are going to do tap water. Water right out of the sink. No.
It's
What would you
water
like
and
to do
milk.
next? Let's do sugar water. Sugar water. No.
Let's do the iced tea next.
Okay, let's do the iced tea next. Iced tea.
I feel like this one. Right?
Yep.
Oh yes.
Yes. Now, because it lit up, I'm now going to rinse off the side of this to make sure that the next one we test, we're actually getting the test on it, not the test from the remnants of the iced tea. What do you want to do next? Let's do vinegar. Let's do vinegar. Vinegar?
Yeah.
Yes.
Do soda next.
All right, let's do soda next. Soda. Root beer. Jolly good. No. Okay. Well, we know what is an electrolyte.
Gatorade.
All right, let's try Gatorade. We know it's an electrolyte. And the light lights up.
Wait, okay, soda and Gatorade. Soda's no and Gatorade's yes.
Soda was no, Gatorade was yes. All right, which one? Orange juice or salt water?
Salt water, I already know that. No.
Orange juice.
Orange juice? Since you're already sure salt water is a no, we'll do it last.
All right. Orange juice, yes.
Now, what do you notice about the brightness?
It's
Very
it's
bright.
Very bright. Has a
So
lot
what do you think that tells us?
a lot of electrolytes.
Ion.
Very good. Probably a lot more ions, a lot more electrolyte in there. That's why it lights up a lot better. So what's the last one?
Salt water.
And what's your thought, Lacavian?
I say
I
yes.
think all the water ones just like didn't really light up. Oh, that was
I was ready.
You shot a break.
Salt has a lot of electrolytes in it.
You're absolutely correct.
Probably the salt. It's the salt.
Okay. So that is all of the ones that we need to get through, ladies and gentlemen. All right, now let's take a look at your questions because you need to finish those questions for tomorrow. All right, so on the lab, did the light bulb, the demonstration that we just did, come on for samples with a high conductivity reading or a low conductivity reading, or was there no pattern? So let me explain what we mean. I'm not asking you to answer this. Not at least out loud on your paper. So these were lower to high, correct?
Yeah.
So somewhere along the line, either we started out with the bulb on and somewhere along the line it stopped coming on, or we started out without the bulb coming on and then it started coming on. If it was on, then off, then on, then off, what does that mean?
It's not a pattern.
Then it's not, conductivity has nothing to do with it. But if the light bulb starts on and then goes off, we could say when we get to higher conductivities, that's when the light goes off. Or maybe when you get to lower conductivity, the light is off, and until you get to a certain number, it doesn't turn on. That's what you have to decide from your results. Okay? That's what you have to decide from your results. You don't need to tell me each thing individually. Why are some solutions conductive and others not? Research the answer. Well, you already did by looking up what the definition of an electrolyte was. To be an electrolyte, it has to create what in the solution?
Electricity?
Nope, the electricity is from here.
No electricity, sorry. The ions.
Ions. So if you have something that does not create ions, it cannot be an electrolyte. But if there are ions that are created, that means it's an electrolyte. Okay? So which things had to have ions in them, because which things did the light come on the brightest? And then is pure water an electrolyte? Why or why not? We showed you tap water. We showed you deionized water. Matter of fact, we showed you sugar water. It wasn't until we got to salt water that the light finally came on. So if it's the water, should have gotten the same result for all of them, correct? Have a good day, ladies and gentlemen. Please make sure you go online tomorrow, figure out what you need to do, and get it done. Have a great day. We will see you later. Goodbye, goodbye, goodbye.
So it's safe to say that it's sulfur that creates electrolyte?
No, it's the what in solution. You have to make what?
The
Starts with I.
ions.
You have to make ions. If you're not making ions in solution.
Why is the salt like?
So what does that tell you about salt?
It has a lot of ions, but
That
like,
it's made up of ions.
so like
What does that tell you about sugar?
doesn't have a lot of ions.
Doesn't have any ions.
But so OJ
You like that?
has sugar and
You like that or no?
It's not the sugar in OJ.
Yeah, I know.
It's
but
the same thing that's in vinegar.
so like what in the salt is it?
You're supposed to
Salt
keep
is-
that over what
itself.
you need to know.
Okay.
But there's also other things that will break apart
got
into
mine.
ions
I'll teach
other
you.
than salt. Sorry, sir. Here you go. So there's something in orange juice. There's something in lemon juice. There's something in vinegar that causes ions to be made. Look it up.
Okay.
Look it up.
Thank you, Mr. Brown.
You're welcome. Have a good day.
You